Okay, so I'm Valentin. Nice to meet you here today. And I'm talking today about AutoML, which is a tool to build classifiers of pictures, photos. But first, a little digression, if I can find it. Okay, so, nope. Yeah. So when I was a kid, back in the 90s, I saw this awesome movie in the theater. It was a stop-motion animated movie in which one of the characters was a penguin. And in the plot of the movie, the police was actively looking for a dangerous criminal chicken. And at the end of the movie, the chicken, it removes its comb. It's not an actual comb. It turns out it's just a red rubber glove. And it's revealed that the chicken and the penguin were the same character all along. Very surprising. So anyway, my point is, if a red rubber glove is enough to protect the anonymity of a penguin, then I think that little black rectangles over the eyes are enough to protect the identity of my two heroes today. Here they are. So let's refer to them arbitrarily as Wallace and Gromit to protect their true identity, obviously. Okay, now back to the real slides. I'll do a demo right now. The reason why I'm doing this right now is because I will upload a few photos to a tool that is Google AutoML Vision. This will train a neural network model that we can use later to make inference. So what I'm actually doing is uploading 100 photos of Wallace, 100 photos of Gromit. I put all of these in a zip. I drag and drop to AutoML Vision, a web service, and then it will take a few minutes to train the neural network. And that's why I'm doing this at the beginning of the talk, and hopefully, if we are lucky, it will be finished at the end of the talk. So let's do it. This is AutoML Vision. I'm gonna, I don't have the screen. Okay. Kind of a bit difficult. No, I don't have anything on my screen. I will have to set up back the mirror display. No, I'm not lucky today. Mirror display. I don't know why it went away. Okay. So this is a web interface of AutoML Vision. I'll create a new dataset. Let's call it WJ. Okay. So what I have on my laptop is a zip. What's inside the zip, it's like pictures. These are the pictures of Gromit. Anonymized, obviously. We can't see his real identity. The structure of the zip is 3 folders, one for Gromit, one for Wallace, and one for random pictures. And this is what I will upload right now. Okay, select files. I select zip. Okay. Open. Did I click? Okay. I click the option. We can't read very well, but it says enable multi-label classification. It's important in case I want to infer some labels from pictures that have multiple labels, like a picture that features both Wallace and Gromit. Okay, create dataset. Then it's uploading. Okay. 3 megabytes, it shouldn't last very long, hopefully. But what it's doing after uploading is that it's importing the images in Google Cloud Storage, and then it's doing some stuff. Actually, I don't know what it's doing, and I will have to ask my colleague because it's lasting for like 5 minutes, and it's not acceptable, I think, to wait 5 minutes to upload 3 megabytes. So so I just prepare another data set in which everything is already uploaded. We have a small warning that says You have some duplicates files, but obviously that was on purpose. I know I duplicated some files in the folder Wallace and in folder Gromit because these photos were featuring the two characters. Okay, and now I will click on train. I cannot use this for prediction right now. These are only the pictures I uploaded. I will now train a model. Okay, let's click train. It says you have enough pictures to be training. That's fine. Start training. So I will give a name to my model, and it's a fairly small model. It should require less than 1 hour of compute, which means it will be free this time. Okay, start training. And this will last like 10 or 15 minutes. So let's back to the slide. What machine learning options do we have? The popular machine learning options these days are all based on neural networks. And on a very high level, we can use vision APIs. This is inference as a service. What it does is that you don't have to train any model at all. You don't have to provide any examples. You just use a pre-existing model and infer and launch inference, which is you provide an input. Here is a photo, and you just click inference because the model already exists. It has already been trained on millions of examples by the service provider. And when you get as a result are a list of labels and confidence. Here the system detected parachuting, sky, and cloud with high confidence, which is correct. Thank you, AutoML Vision, Vision API, Google Vision API, but this is some generic information. Like if in this picture the system tells me it's probably lime or lemon, and the second picture is with very high confidence lemon, that is correct, but maybe not exactly what I need, what I want in my application. I mean, if I'm a lemon farm, I'm not interested into knowing that these are lime or lemon. I already know the variety of my fruit. What I would be interested in would be, are those fruits ripe or are they still immature? If they are ripe, I can sell them today on the market. And if they are immature, I have to wait another day. So that would be much more interesting for me, specific information for my domain model. Do those fruits look ripe? 30%? No, not really ripe. Or we're not sure. And in the second picture, yes, it does look ripe with high confidence, 95%. Okay, so that's important. With Vision API, you only get some generic information that are difficult to take action upon. The inference is much more useful when it is actionable. So here are a few examples. If a user uploaded an inappropriate picture to my platform, this is very actionable. I can trigger the server to delete the file immediately so that no one will see that children, etc. Or if I'm in a factory and I take a picture of an item and it looks like an item that is appropriate to go on conveyor belt number 4, then this is very actionable. You put the item on conveyor belt number 4. Or if my fruit, my lemon, is still immature, this is very actionable. Put it aside, wait another day before selling it on the market. So I need a custom model and custom labels for my specific domain. What can I do? At the lower level of machine learning options, I can build a neural network from scratch. That will require a fairly large team of data scientists and software engineers, design everything, code everything, come up with model graph. So it's a neural network in which we have settled upon a certain number of layers, certain number of neurons, and it's still blank in the sense that the final weights have not been set yet. That's the training phase. So we provide it with hundreds and hundreds of photos or pictures annotated, labeled. That's the training phase that sets the weight. And at the end, the output is a model. And the model will then be used for inference. Okay. On a slightly higher level, we can use TensorFlow to build a model from scratch. So it looks like the previous slide, but you need a smaller team of data scientists and software engineers to use TensorFlow as a framework in Python to design a neural network. And then you still need the big training set, and that's a lot of work to gather some relevant training set. And in less time and less money, you get a nice model tuned for your needs. Okay. Now, third option, which is really interesting, you can use TensorFlow for transfer learning. Quick poll, raise your hand if you've already heard of transfer learning. Okay, not that many. That's great. Transfer learning is a really powerful technique in which you can leverage an existing generic neural network and train a new neural network by injecting your data at the end. So in this graph, the existing neural network is on the left, and it has been trained on millions and millions of pictures. And the lowest levels, the lowest layers detect some low-level features like this is an angle, or this look like a curve, or this is a color transition. It uses technique like convolutions, etc., a lot of complicated stuff, but it's not yet generic to your domain. And transfer learning consists in adding a few hidden layers at the end and create a new neural network trained with your data. You can see here pictures of lemon. That would be my data. And so I will be able to leverage something that has been trained on millions of photos and adapt it to my specific domain. This is really useful and gives powerful results. This is what it looks like. You still need a few data scientists who are proficient in Python and TensorFlow. And what you get in the middle is a model graph in which the first layers have already been trained and not yet the last layers. Then you inject your training set, and at the end you get a very customized and accurate model. Okay. That still requires a team of data scientists, 1 or 2 people. Is there something in between? Something that could mix the best of the 2 worlds, which is low configuration like in the Vision APIs, in which you basically do nothing but inference, but still be powerful and adapted to your custom domain like the TensorFlow or custom neural network options. Turns out this is called AutoML. In a generic sense, I'm not meaning some specific vendor. AutoML is the principle that you just upload some training set. The training set consists in pictures and labels, so it's supervised learning. You give examples with the questions and the answer. This is my picture, and this is the right answer for this picture, the appropriate labels. Then the AutoML system will do everything needed to train a neural network and provide you at the end with a model. So this is what it looks like. For the user, the first part is identify a problem, then gather and pre-process a lot of data, preferably hundreds or thousands of examples. And then the standard process for the user would be to split data. Here are 80% of my pictures for the training, 20% of my pictures for the validation and the evaluation, then launch some training and deploy the model, etc., make prediction. And AutoML automates a lot of these steps. It splits data for you. If you just upload 1,000 picture, it will automatically figure out that it needs like 800 for the training and 200 for the validation. It builds a model for you. It decides by itself if it needs a convolution, how many layers, etc. It does the training and evaluation. If it's not good enough, it trains again, etc. And when I say deploy model at the end, it's about hosting the inference service. And most AutoML solutions propose some kind of hosting, like Google Cloud Platform. Okay, I must emphasize that there is still work to do. AutoML doesn't do everything for you. And gathering and pre-processing data, this is still a lot of work, of a lot of human time to be invested. So just because there is auto in AutoML doesn't mean there is no work. I cannot overemphasize how important it is to gather numerous and relevant examples, and that's the work of a data scientist. Okay, so the input data set, what does it look like? It's over 100 pictures per label, and you can provide low resolution pictures. It doesn't really matter if it's high resolution. So what I did for Wallace and Gromit is I just took a very low resolution from pictures from an image search, and that was perfectly cromulent. That was enough. Okay, so now for the AutoML provider, the challenge is to provide a good UX. How the developer, the data scientist, will be able to provide the example and launch the training. So we need some kind of format to provide the files and the labeling to the AutoML system. Quick review of some tools. So there are a few competitors in the AutoML market. One of them is Machinebox. So what does it look like? You sign up on the web page, then you pull a Docker image, and everything will be happening locally in the Docker image. So you don't need a cloud to use it. Everything can run locally on your dev box or on your own data center or cloud. You decide. It's just a container. And it's not a web UI. It's a REST API. So for example, this is the JSON as a payload that you will use to create a new model with two labels, Wallace and Gromit. Okay. Then you can use curl to send that payload, and you get some JSON as a result that says success. I just created this new model with two classes. Okay, fine. Then you still with curl, you will send the pictures and the labels to be trained. Okay. And so I made up a small bash script that would work all my files and all my directories and do a curl to train each images. And then I figured out that I didn't need to write that script myself. Some command line tools were already available, provided by Machinebox to do the same. Okay. So now the inference, it's still a REST API. So inside payload infer.json, I have the base64 encoded picture of this animal. And I will ask the model, hey, what does that look like? And in JSON, I got the answer. With 80% confidence, I think this is Gromit, which is correct. Good, Machinebox. So unfortunately, I won't have time to say everything about every vendor. I'll skip rapidly to next vendor. On Microsoft Azure, there is custom vision. And I really like this one because it's fast. It has a nice UI that resembles Google's one. So What takes time with Microsoft Azure was setting up an account and logging in. I don't know why every time I do that, it takes me a long time, but then everything is very fast. I create a new project, I give it a name, I set up a few options, I say it's for classification and it's multi-label. And here it says in the domains that I can select some options that would allow me to download the model to Android or iOS device. That is a really nice option that is currently available in Microsoft Azure Custom Vision. So I upload my pictures and the labels. So what I did basically was to say, now I'm uploading all the Gromit images. So it's implied that all this import will get the label Gromit. I do the same for Wallace. Okay, and then it starts training, and it's really fast. Like in under 30 seconds, I have a model, and I can test it with inference. It tells me, it tells me the precision and recall numbers, which it's the performance of the model, not the performance is in terms of speed of latency, but more in terms of accuracy. So I always remember, forget which one, but one of them, the recall, I think, is to say among all of the pictures of Gromit, how many percent have been correctly labeled as Gromit by my inference model on the validation set. So here 86%, okay. And precision, it's whenever my model is predicting this looks like Gromit, what percentage of the time is it correct? So recall and precision are two accuracy numbers that always go together. So here I tested it. I uploaded in the web UI of Microsoft Azure a picture of this person, and with 99% confidence, it told me it is Wallace, which is correct. Well done, Microsoft Azure Custom Vision. Then if I upload this animal with 99% confidence, it's Gromit, which is correct. Then a picture of the two of them. With 95% confidence, there is Wallace, correct, and only 12% confidence it is Gromit. Okay, so we have a glitch here. It has difficulty to detect all of the labels in a picture that contains many of them. Okay. Then with something unrelated, just to test the model, this guy with 93% confidence is Wallace. This is not correct. And that's why it depends on the vendor you're using. It's sometimes important to train not only on positive examples with Wallace and with Gromit. Sometimes it's important to also train the model with unrelated photos and to label them with 0 labels or a special custom label, which is called none of the above, for example. Okay, Clarify. So Clarify is another provider. Okay, you sign in, and then it has client libraries in a few languages, which is nice, like JavaScript, Python, Java, etc., and REST API that you can call with curl. And so you use some kind of script, curl, etc., to create new models and upload the photos. Okay, this is my script, my bash script, similar to the other one, to send all of the photos. And then I quickly get into accounts limit exceeded, so I should do some back and forth with support to get higher limits, but I didn't have the time to do that yet. Sorry. Okay. Now AutoML, Google Cloud Platform, AutoML Vision. I hope my model is ready now. So let's check in the web interface. Yes, I have evaluate and predict tabs, so I can predict now. So in the evaluation, it automatically took a validation set and detected it has 85% precision and 92% precision. It's important to know that these numbers depend on the threshold. The confidence threshold here is set to 50%, which means whenever the system has confidence over 50% that this is Gromit, it decides that, hey, this is Gromit. And this is how it computes the precision and recall. And if I want to be more strict and have high confidence only, this will increase recall, I think, and decrease precision. And the other way around, you can see the curves just under here. So you can always decide to have higher precision and lower recall, or the opposite, to have higher recall and lower precision, depending how sure you want to be of the answer when you get the answer. Okay, let's predict. I'm gonna upload first image. Okay. What does this look like according to Google AutoML Vision? It looks like Wallace with 99% confidence, which is correct. I must emphasize that this picture, I didn't upload it to train the model. It was not part of the training set. It was not part of the evaluation set that I gave to Google to compute the precision and recall. It's another file that the model has never seen yet. And it correctly predicts this is Wallace. Okay, let's try with another one. With 99% confidence, this is Gromit, which is correct. And it has a very, very tiny chance to be Wallace, but only 4% confidence. It's correct to say it's not Wallace. Let's try another one. Both of them. Okay, so it correctly detected Gromit and Wallace. High confidence for Gromit, slightly lower confidence for Wallace, but 62% is still above my threshold of 50%. So I say, yay, it correctly detected both of them. Let's try with the last one. Can you read on the screen, or is it too small? Blurry, okay. Is this better? Okay, so I didn't lie to you. It's actually 86% confidence for Gromit and 62% confidence for Wallace. Okay, let's try a last one. So, with 81% confidence, this is none of the above, a special placeholder label that I created to say it's not Wallace and it's not Gromit. So what I actually did is I selected 200 random pictures on the internet and I uploaded all of them to say none of the above. It's really important to do that because otherwise it would have detected probably Wallace like the other systems. And also I took care to include dozens of other clay animation characters inside my none of the above folder, so that it's the model will be able to detect that even something like that looks like a clay character is not always Wallace and not always Gromit. Okay, I think that's it for the demo. I still have a few slides. So as I said, recall, precision, they go together and they depend on the threshold. So higher recall, lower precision, and vice versa. I have a choice between two strategies. Shall I upload all of the pictures of Gromit containing only Gromit and all of the pictures of Wallace containing only Wallace? Or shall I upload in the same folder some images that have multiple labels? I can just test the two strategies and see which one yields the best inference accuracy in the end. And it turns out that I get a better precision and the same recall if I have a folder label with two labels, Wallace and Gromit, and I upload it to AutoML Vision. Training on negative examples, that's what I was talking earlier. If I don't provide some unrelated photo with Google AutoML Vision, that guy will be predicted as Wallace with a 99% confidence. And if I do include negative examples with the placeholder label none of the above, then it correctly detects that this is not Wallace and this is not Gromit. So AutoML Vision, it also provides a REST API. So you have everything you need programmatically to do the import, the training, etc., and then the inference. There is a nice web UI that I showed you in my demo, but your program doesn't have to go to the UI. You have APIs for that. So the server is automl.google APIs. Okay, you need a security token. It's more convenient if you have gcloud to get a security token. And then the curl command will look like that. You have a JSON payload, a security token, and you get the answer in JSON as well. Client libraries are integrated with a few languages, Python, Java, Node. So that might be more convenient than curl, depending on your environment and your project. And in summary, AutoML Vision for some use cases are really great because it's easy to use, it's fast. Most of the automatable work, every step that could be automated has now been automated, and this is actually a huge win. That's why I like AutoML solutions, even if you can't tune a lot of parameters. And usually it's fine. It just takes the right decisions for you and it saves you time. I cannot overemphasize how important it is to spend time, weeks and maybe months to gather and to cleanse your data. This is not an automated part of the job. It's still the job of the data scientist to do that. My other tip is to design actionable labels. Something that makes sense in your domain, in your project, and that you can take actions upon, like in the conveyor belt example. I take the item and I put it on another conveyor belt. And it's so easy and straightforward to test that I encourage all of you to try some of the solutions, some of the vendors I've presented today, because you will know really fast if the results are good enough for your use case and if you can integrate it in your project. A little advertising for other artificial intelligence related talks today. So we have AI JavaScript Rocks with Asim Hussain, serverless tools for machine learning, big data and app end with my colleague Brett McGowan. This is this afternoon, yes. Music and AI in the browser with TensorFlow and Magenta.js. It's a ML full world, ML kit for Android devs. So 4 other talks that are related to AI today. And you also have nice online resources on Google AutoML Vision. So a few videos by Sarah Robinson, and also one that I really like by Yufeng Guo. It's about how to build efficiently a training set consisting of hundreds of thousands of pictures. Actually, what he does, and this is brilliant, he takes a video of the objects that he wants to learn in various angles and zoom and light, and then each frame of his video became one training set photo. So in no time he comes up with thousands of pictures. This is really brilliant. I love this technique. That's it for today. Thank you very much for listening. And do you have questions?